Welcome to Math TV with Professor V. This is video lecture for college algebra on section 1.7, problem solving, and we're going to do some interest problems, mixture, uniform, and constant rate job applications. Don't worry if that sounds totally weird. We'll just walk through it right now. So here's some steps for setting up applied problems, aka word problems. First one says, read the problem carefully. You know, honestly, I like to read it really fast the first time through and just skim and see what the key points are, and then I'll reread it slowly. So I don't know if I agree with step one, but every book says to do that. 2, assign a letter or a variable to represent what you're looking for. We're going to solve all of these applications just using one variable. And if it's not obvious what to let your variable, usually x, represent, most of the time, let x equal the quantity that you have the least amount of info on. You'll see what I mean in just a second. Okay, sometimes it's obvious though. 3, make a list of the known facts and translate them into mathematical expressions. 4, solve the equation and then answer the question. That's important. Always go back, make sure after you find x, that's not necessarily the answer every single time. So go back, make sure, did I answer the question? And then check the answer with the facts in the problem. Just check it out to make sure it makes sense, okay? So first one's gonna be an interest problem, and the formula to computing simple interest is that I, that's the amount of interest that you have, is equal to P, the principal, how much you invest, times R. R is your interest rate, and R needs to be a decimal when you put it in the formula, okay? Decimal interest rate. So not as a percentage. Okay, so let's look at an example here. A bank loaned out $12,000, part of it at a rate of 8% per year, and the rest at a rate of 18% per year. So we don't know how they chopped up the $12,000. Did they do 6 and 6, 10 and 2? That's our job to figure out. If the interest received totaled $1,000, how much was loaned at 8%? So we know the total interest is equal to 1,000. That's the interest that comes from the amount loaned at 8% and the amount loaned at 18%. Somehow at the end of the day, at the end of the year, the total interest was $1,000. So right here in the question is a clue how to define our variables, because they said how much was loaned at 8%. So I'm just going to let x equal the amount loaned at 8%. So what would represent the amount that was loaned at 18%? Well, remember we had $12,000 total, right? So pretend that $2,000 was loaned at 8%. How would you figure out how much is loaned at 18? You would do 12,000 minus that 2,000, right? So it's just 12,000 minus whatever x is. The rest of it, that's how we represent the rest of it. That's the amount loaned at 18%. Okay? And the total interest at the end of the year is equal to the interest from the amount at 8% plus the interest from the amount loaned at 18%. So now I'm going to use I equals P times R and solve for x. This x and 12,000 minus x, those are the P, those are the principal amounts that were invested. Okay, how are we doing? You're all right? No one's had a meltdown yet? Okay, so the total interest, they told me that was $1,000. That's going to equal the interest at 8%. So at 8%, the principal P, I'm doing P times R, P times R. The principal at 8% is x, and the interest rate R is 0.08. Plus, now the interest for the amount loaned at 18% is going to be the principal, which is 12,000 minus x times, change that interest to a decimal, the interest rate 0.18. Now we just have to solve. Can you solve this? This is going to be 1,000 equals 0.08x plus We got to distribute. You can get your calculator. 12,000 times 0.18 is 2,160 minus 0.18x. Okay, I'm going to subtract 2,160 from both sides. So this is going to be negative 1,160 equals, these are like terms, I can combine. 0.08x minus 0.18x is negative 0.10x. And then divide both sides by negative 0.10. So x is equal to 11,600. Okay, so let's see if we answered the question. How much was loaned at 8%? And I found x, and x is the amount loaned at 8%. Oh, look at us. And that's all they wanted. Woof, then we're done. Just write it out nicely. So $11,600 was loaned at 8%. Some teachers will require a full sentence. So if that's the kind of teacher you have, do it. I'm cool with this though, you know. Just label it, put your units on, we're good. It's not English class, I don't like writing so much. Okay, good. Now we're gonna do a mixture problem. We're not gonna talk about weird chemicals. We're gonna talk about something near and dear to a lot of people's hearts, coffee. So a coffee manufacturer wants to market a new blend of coffee that sells for $3.90 per pound. Okay, they've decided that's how much it's gonna sell for, cool. By mixing two coffees that sell, singular, for $2.75 and $5 per pound respectively. What amounts of each coffee should be blended to obtain the desired mixture? Okay, so what we're going to do to help us solve this problem is we need to assume what the total amount is to help us out, and a nice number to use is just 100. So I'm going to assume we're making a 100-pound mixture total. And the setup you're going to see is very similar to this interest problem that we just did, okay? So we've got two kinds of coffee, a cheaper one for $2.75 a pound and a more expensive one for $5 per pound. So let's let x equal the number of pounds. You could do whichever one you want. I'll say of the cheaper, the $2.75 per pound coffee. And then the other coffee is going to be represented by 100 minus x. So x is the total, x is the number of pounds of the cheaper coffee, 100 is the total number of pounds. So this is 100 minus x is how many pounds we have of the $5 coffee. And we're going to mix them together, and the price better come out to be $3.90 per pound. So we're basically making a cost equation, okay? So if we have X pounds of coffee that costs $2.75 per pound, the total cost would be $2.75 times X plus, we're multiplying these by each other. The number of pounds of $5 coffee is 100 minus X, and it costs $5 per pound. So the total cost for that coffee would be 5 times 100 minus X. This is our blend. Cheap coffee, expensive coffee. And it better come out to be $3.90 per pound. So $3.90 times the total number of pounds, which we assumed was 100. You could assume any number you want. You could assume this is 25, then this would be 25 minus X. You could assume it's 47, and then you'd have 47 minus X. The answer won't make any difference in the end, okay? But what number is nicest to work with? I would say 100 in this case, right? Okay, so we've got 275x plus, distribute your little heart out, 500 minus 5x equals 390. We can combine some like terms, right? These both are x's, so 275 minus 5, negative 2.25x. If I subtract 500 from the other side, I'm going to get negative 110. So now I'm going to divide both sides by negative 2.25. Okay, and you get as a decimal, you get 440 over 9. That's not a decimal, that's a fraction. I reduced it in my calculator. Okay, so what exactly does that mean? That means for the coffee that was at $2.75 per pound, of the 100 pounds, 440 over 9 should be the 275 mixture. That number isn't very helpful. So let's just figure out as a decimal what it would be. So 440 divided by 9 is going to be 48.89%. So that's more helpful to us because you may not necessarily be making 100 pounds total, but however many pounds you're making, 48.89% should be the cheaper $2.75 per pound coffee. Okay, and then how could we figure out how much of the more expensive coffee we need? Just do 100% minus 48.89 and you get 51.11%. So that's the percent of the more expensive $5 per pound coffee. Okay, and it worked out nicely that I got percentages because I assumed 100 pounds total, you know? Okay, let's box this nicely. We're so proud of our work. And just check with your instructor too how they want the final answer, but I think percentages make the most sense. Okay, good, good. Hang in there, just a couple more. So now we're gonna do a motion problem or a uniform motion. So the formula to find velocity, V, you've probably seen distance equals rate times time. When you switch over into more physics, you start calling it velocity. S is your position. So V would equal S divided by T if I rearrange this formula, which you'll need to do sometimes. And then similarly here, if you need the rate, it's equal to distance divided by T. We won't need to do that though for this next example. So we have two cars that leave point A at 8 o'clock a.m. heading to point B. One car's average speed is 10 miles per hour more than the others. The faster car arrives at point B at 11 a.m., half an hour before the other car. So one gets there at 11 a.m., one gets there at 11:30. What was the average speed of each car? How far did each travel? So we need the speed of each car. There's a faster car and a slower car. Which one should I let X be? This is where you're going to use that tip where I said, let X represent the quantity that you have less information about. So notice here they said, one car's average speed is 10 miles per hour more than the others. So they told me info about the faster car, didn't they? That its speed is 10 miles per hour more than the others. But they didn't tell me a single thing about that slow little car. So that's what X is going to represent. So I'm going to let X equal the speed of the slower car. I'll just call it car number 1, okay? And then the speed of the faster car, since they told me it's going 10 miles per hour more, then it would be represented by X plus 10. So that's the speed of the faster car. We'll call that car number 2, okay? So now let's figure out the distance that each car traveled using distance equals rate times time. So car 1, slow car. The distance that it traveled from A to B is equal to its rate, its speed, which is X, times T. How long did the slow car travel? It traveled from 8 a.m. until 11:30 a.m. So that's 3.5 hours, 3.5. So this is just 3.5x. What about car 2, the faster car? So its distance was equal to its rate. Its rate was X plus 10. What was the time that it traveled? Only from 8 a.m. to 11 a.m. So it only traveled for 3 hours. And this I can simplify if I distribute 3x plus 30. Okay, well, what do I know is true? The fact that these two distances are equal to each other. Both cars traveled from A to B. So I can set 3.5x equal to 3x plus 30. So since they traveled the same distance, this means 3.5x equals 3x plus 30. Whew, the worst is over. Now we're just going to solve. So I can subtract 3x from both sides. I'll have 0.5x equals 30. Divide by a half, that's the same as multiplying by 2, so x equals 60. So what did x represent? The speed of the slower car. So the slow car, number 1, travels 60 miles per hour. And then the faster car, they told me, travels 10 miles per hour more. So it would travel 70 miles per hour. Personally, none of these are appropriate speeds if you're on the freeway where I live. I think 80 is a good bare minimum, but whatever. And then last thing, they asked us for more info. Look at these demanding folks. How far did each car travel? So we need the distance. So you could, it doesn't matter. You could compute the distance using 3.5x or 3x plus 30. They're going to give you the same number. So you just decide which one looks nicer to you. Let's do 3x plus 30. Why not? So 3 times x is 60 plus 30, that's 180 plus 30. So this is the distance. So they traveled 210 miles. Okay, that's it. Let's box our final answers. Make life easy for your instructor. Last one. These are some of my favorite. I like to call them work problems because they describe tasks or jobs that need to be done. Okay, constant rate job, whatever. So Bob by himself can paint 4 rooms in 10 hours. What a champion, Bob. Okay, if he hires Mary to help, they can do the same job together in 6 hours. Ooh la la. If he lets Mary work alone, how long will it take her to paint 4 rooms? So don't stress about the fact that there's 4 rooms. That's really just in there to maybe mess with you. Just think of it that they're painting a house. Who cares how many rooms are in it, okay? Because it's consistently 4 rooms every time they talk about this painting job that they complete, okay? So don't think about chopping stuff up by 4, not necessary. What's the question saying? How long will it take Mary to paint the house? The less numbers, the better. Okay, so let's let x equal the time it takes Mary to paint by her lonesome. Now you can make a table and all that. Some teachers love it. I just jump straight to the equation. It's not that crazy. You can do it. So what you want to do is write an equation that represents how much of this task, this job has been completed in 1 unit of time. The time that we're measuring everything in is hours for this problem. Okay. So let's see what's happened, what's been completed after 1 hour. Okay, so Bob has completed some of the job plus Mary, and that's going to equal how much is completed together. Okay, so if it takes Bob 10 hours to do the whole house all by himself, if only 1 hour goes by, what fraction has he done? What fraction has he completed? 1/10, right? Just 1 over the total time. Plus, now it takes Mary X hours to paint. I don't know how many hours it's going to take her by herself, but after 1 hour, she's gotten 1 over X done. Yes? And adding these up gives me the portion of the total job that they get done together in 1 hour. Well, together it takes them 6 hours. So after 1 hour, they've gotten 1/6 of the job done. See, and then that's your equation that you're going to solve. Not too crazy, right? How do you solve this equation? It's a rational equation because we've got variables in the denominator. We want to clear out these fractions, multiply by the LCD. The LCD is 30x, yep. And multiply everybody by 30x. So if you need to, if it's hard for you to distribute in your head, okay, don't be ashamed. You can just write next to each term, 30x over 1, 30x over 1, 30x over 1, like that, okay? If you're more comfortable and confident in your algebra skills and you don't need to, you can just write it with the bracket and distribute like I showed you a second ago. Okay, let's go simplify term by term. So 10 will cancel. This is a 3. We've got 3x plus, this x cancels, 30 equals, 6 cancels. This is a 5x now. Oh, look at what a non-threatening equation. I love it. So 30 equals 2x. X equals 15. What was x? The time it takes Mary to paint. That's exactly what we had to find. So how long will it take Mary to paint 4 rooms? It takes Mary 15 hours. Poor thing. I hope Bob helps consistently. Okay, so that concludes the lesson. The thing with applications, word problems, they're scary until you practice them a bunch, you know? And I'm going to tell you a little story. I used to help run a tutoring center at a campus I taught at, and we'd hire students to tutor, usually like my calculus students, and they would tutor intermediate algebra. And the first semester that they were on the job, they'd always be so nervous when algebra students came in and they had, you know, these kinds of exercises as their homework. But let me tell you, they'll all say after 1 semester tutoring, you get so confident and the word problems become no big deal because you understand the setup and they're all pretty much following the same pattern. It's just a lot of repetition and practice that gets you to a point where they're not intimidating. Okay, so if they still freak you out, just keep at it, because eventually when you do enough of them, you'll see the general big picture and understand that really they're all just the same problem. Whether or not they're painting a house or mowing a lawn, the setup for all these is the same. These distance problems end up pretty much the same. This one you could be mixing coffees or nuts or chemicals. It's all the same. So essentially you'll kind of generalize and be able to knock these out no problem. That was my little pep talk to you. So anyways, give this video a thumbs up if you haven't already, if you found it helpful, and subscribe to my channel. And then stay tuned. I got a lot more video lectures coming your way, especially on calculus.